All right, so this is going to be chapter 5 and 6, trigonometry review. So there's going to be a lot of things from trig that you may have forgotten, but a lot of it should feel very fresh as opposed to the algebra stuff that we were learning in class. So we're just going to be going through some topics. Not everything that you learned in Math 104 will be on here, but here are going to be some of the basic stuff that I really want you to know. So let's first start off with radians. So 1 radian is a measure of the central angle of a circle such that the length of the arc between the initial side and the terminal side is equal to the radius of the circle. So if you remember from trigonometry, we got this circle, and let's say you got this radius, okay, and you're looking from the initial side. So let's say this is the initial side, and all the way to the terminal side. So this may be where the angle stops. So here's maybe angle theta. So basically what 1 radian means, let me go ahead and make this a little nicer. So this is angle theta. So what this basically means is a radian, okay, is going to be equal to whenever this length of this guy, let's call that S, is equal to this theta. That's what 1 radian is. Okay, so 1 radian is equal to the measure where the length of the arc is equal to the radius of the circle. So let me highlight that. So length of the arc, which is the S, is equal to the radius of the circle. Okay, and here I do a little bit of a derivation. So one way to find the arc length of an arc of a circle is the radius times the angle theta. So if the radius is equal to 1, for example, we can plug that in and we can see that S is going to be equal to theta, because just plugging in the 1 will give me 1 times theta. So if you're thinking about how much the circumference of a circle, or how much this is, right, or the length of this, you can also think about it as the circumference, because the circumference is basically distance of a circle. It's just equal to 2 pi r. Since r equals 1, we see that c is equal to 2 pi. Okay, so that means the circumference, the length of this guy, is equal to 2 pi. But we know that 1 full rotation is 260 degrees. So if we think about it, 2 pi radians, which is basically this whole arc, is equal to 360 degrees. Okay, remember this, the length, right, is equal to the radian. That's why we have 2 pi radians there. So 2 pi is equal to 360 degrees, which is also equal to 1 rotation, or you can call it 1 revolution. So if we divide everything here by 2, you'll see that pi radians is equal to 180 degrees, which is also equal to half of a rotation. So this is something that you should know how to do, because, and probably one of the things that it's very easy to remember, because you've done it maybe a lot of different times. So here are some really useful degrees and radians measures. So you have the degrees here on the towards the inside, and on the outside we got the radian measures. So this one you must know. So at least know how to be able to locate some of these angles. So you must know this. Okay. So one of the things that we want to be able to do is mainly use this particular conversion to be able to change from radians to degrees. So let's start off with the first one. So let's say we wanted to convert this guy, this pi over 9, to degrees. Notice that this pi over 9 is not on the unit circle, but we can still convert it to degrees. So pi over 9, so we're going to have pi over 9. And one of the things that we got to do is that right now we have radians. So I'm just going to write radians for now. Typically we don't write radians. We just leave it blank. So we know that in pi radians, there's a total of 180 degrees. So you can see that the radians cancel out. Also the pi's cancel out. And we just have 180 over 9 degrees. Okay. So when we take 180 and divide it by 9, that's just going to give me 20. So this gives me 20 degrees. So pi over 9 radians is equal to 20 degrees. All right, now let's look at converting to radians. So here we have beta is equal to 410 degrees. So we're going to take the 410 degrees and use the same conversion factor that we have above. So this pi radians equals 180 degrees. So now we know that 180 degrees have to go on the bottom to be able to cancel out the degrees. And you have pi radians on the top. So you're going to end up, so the degrees basically cancel out. So we got 410 pi over 180 degrees, or 180, okay, because now it's in radians. So you can put that in your calculator to try to get a better view of what this is. This will actually be 41 over 18 pi. Now, typically, these guys, you don't want to make them into decimals. You will typically want to keep them in exact answers. But just being able to get the exact answers are also nice. One more thing before we continue. Sometimes you're not going to see these angles theta and beta. So remember, this theta is just a Greek word, theta. You might see alpha, which kind of looks like a little fish. This means alpha. You might see a B, which is called beta. And you might see something that looks like this, which means gamma. So all of these guys, all of these symbols usually denote angles, okay, angle measurements. So don't be surprised when you see them. This same thing as theta is just different way, just how we have x's, y's, z's, t's to represent different variables. We also have different variables for angles, and typically we have them as Greek letters. Sometimes you can use t, so sometimes you'll be using t for an angle measurement, or of course we'll use x as well. All right. So so now let's go ahead and remember our 6 trigonometric functions. All right. So given an angle in standard position. So again, when I think of standard position, I always think of the positive x-axis. So this guy. So starting from here, this is actually where 0 starts. So it's either 0 degrees or 0 radians. You can basically find any angle that I want, right? So maybe I can go to the second quadrant, and that will give me an angle. So this will be the initial position. Okay, and this will be the terminal side. The initial side and the terminal side. And this is what we call standard position. Standard position means that it starts at 0. So when we think about this, the 6 trigonometric functions are defined as follows. So these guys should be very, very familiar to you. So again, here's the abbreviation and the function. So we have the cosine of theta, the sine of theta, tangent theta, secant theta, cosecant of theta, and cotangent of theta. So obviously we don't write the whole word down. We have an abbreviation for them. And we have some sort of formula for it. So here the cosine of theta is equal to the x value divided by the r value. Here, r is basically from the Pythagorean theorem, which is the square root of x squared plus y squared. Okay. So if you're given an x value and a y value, you can go ahead and figure out the r value very easily by doing the sum of squares. So cosine of theta equals x over r. Sine of theta equals y over r. Okay. Tangent of theta is y over x. Okay. And then you got the secant, which is the reciprocal of cosine. So you can see that these guys are flipped. So it's r over x. Cosecant is the reciprocal of sine, which is r over y. And cotangent is the reciprocal of tangent, which is x over y. All right. And of course, you can use the unit circle to reference all of the 6 trigonometric functions. Okay. So if you were to find, and I put a little practice here. Because this is a unit circle though, okay, remember this is unit circle, here the radius is equal to 1. We know that this is a unit circle, right? Unit means it's a circle of radius 1. That means that in this case, we can actually make this a little nicer. So basically, because r is 1, now the cosine of theta will be the x value. The sine of theta will be the y value. Tangent of theta is still kind of the same, all right, which is just going to be y over x. The secant of theta would be 1 over x. the cosecant of theta is 1 over y, and the cotangent of theta would be x over y. Okay, so we still got everything to be kind of the same. Now, one of the things that we have to be very careful with is making sure that there's no zeros on the denominators for whatever has fractions. The radius can never be 0, so these guys are kind of off the hook. But the secant, cosecant, cotangent, and tangent, you have to be very, very careful that the denominators are not equal to 0. Okay, then they will be undefined. And you have asymptotes, and we'll talk about those later. Okay, so for right now, let's just look at the unit circle and try to get some points. So let's say you wanted to figure out what the cosine of 7 pi over 4 is. So one good way to do is you can use a calculator and set it to radian mode. But another way that you can do it is just look at the unit circle. So 7 pi over 4 is on the unit circle. It is in quadrant 4. So it's right here. And remember that in the unit circle, you have a point here. And the way that we figure out this point is, or what the cosine of 7 pi over 4 will be, we go onto this side. Remember, the cosine is the x value. So in this case, this is just going to be the square root of 2 over 2. That'll be there. So what would the secant of 5 pi over 6 be? So the secant is the reciprocal of the cosine function, okay? Or you can kind of think about it as 1 over x. So we're going to locate 5 pi over 6. So 5 pi over 6 is right here. Okay. And now notice that we're looking at the x value. So we're just going to flip this guy. Okay, so notice that the x value was negative square root of 3 over 2. So we're going to flip that to negative 2 over square root of 3. Now, typically, this would be the correct answer, right? Because you're just flipping it. Secant is just 1 over x. You're just flipping the x value. One way that you can make it a little nicer is by rationalizing. So multiplying it by the square root of 3 to the top and the bottom. So you get negative 2 square root of 3. Square root of 3 and square root of 3 gives me square root of 9. So this gives me negative 2 square root of 3 over 3. So that's just another way to do it. Okay, let's just do a couple more. So let's say we wanted to figure out the tangent of pi over 2. What would that be equal to? Well, the tangent of pi over 2 would go up here. So here's pi over 2. And what we're going to be looking at is the tangent. And the tangent in this case is going to be the y over the x. So in this case, the y, here's the x and here's the y. The y is going to be 1 over 0. Notice that you can't have anything on the 0. On 0 on the bottom is not okay. So this guy actually is going to be undefined. So you cannot define tangent of pi over 2. Now, what would be the sine of negative pi over 2? All right, so now here's where it gets a little tricky. So one thing that you have to recall is that all of your positive angles are going to go clockwise, counterclockwise. So counterclockwise will yield positive angles. And then if you have clockwise, so starting from starting position going this way, so clockwise will yield negative angles. So you kind of have to count backwards. So notice, starting from here, from the unit circle, going this way is giving me the positive angles. So you get the pi over 6, pi over 4, pi over 3. But if I start going the opposite direction, so now if I go this way, I'm going to get negative angles. So instead of this, so now this was pi over 6. So if I go downward, this is negative pi over 6. This will be negative pi over 4. This will be negative pi over 3. This will be negative pi over 2. So imagine that this is a mirror image of the top guy. So it's basically getting all of these angles, swapping them, and making them negative. So if you look, negative pi over 2 is not this guy on top. It's actually this guy down here. Let me put it in a different highlighter. So this guy is just going to be this guy. So the equivalent to that. And we call these coterminal angles. Okay, so these two guys, negative pi over 2 and 3 pi over 2, are coterminal angles because if I subtract 2 pi, okay, you end up getting negative pi over 2. So these guys are coterminal. Let me write that down. So what would be the sign of negative pi over 2? So that we're going to be looking at the angle where 3 pi over 2 is at. So the sign will be just the y value. And notice that the y value in this case is just negative 1. Okay. All right, so you can go ahead and play a little bit around with this. Another thing that you can do to kind of make this a little easier for you, this is mainly for students that don't have a precise calculator, or when you put in 7 pi over 4 in your calculator, you don't get square root of 2 over 2, you end up getting something funky. You end up getting the decimal form. If you have that type of calculator, it's better to just use a unit circle so that you can get the exact answers. If you have the TI-36X Pro, make sure that you set your mode to radians. So right below, you're going to see the second button. And right after the second button, you'll see your mode button. So press that mode button. And then in the very first one, you'll see degrees and radians. So make sure that your mode is set on radians. Okay. So once you click on radians, you should have at the very top of the screen, you should see rad. So then you should be able to do the cosine, tangent, and sine of these other functions. Now, unfortunately, secant, cosecant, and cotangent aren't in there. So, for example, if you wanted to know what the secant of 5 pi over 6 would be, one thing that you would have to do in the calculator would have to write 1 over, well, think about what the opposite of secant was. In this case, it will be cosine. So it'll be 1 over cosine of 5 pi over 6. So you can go ahead and try that try to put that in your calculator. Put 1 over cosine of the 5 pi over 6. And what you should end up getting is a negative 2 square root of 3 over 3. Okay, so definitely try that to your advantage. This is mainly for those students that have the TI-36. If you have the TI-36X Pro, it'll give you the exact answer of this guy.